So we're looking at the general form of the quadratic. And the general form of the quadratic basically looks like this. It's the expanded form of the graphing form. Okay, so basically we're just getting rid of all the brackets, combining like terms, and then making it equal to 0. So this is called the general form of the quadratic. And the coefficients on A and C help us establish what type of quadratic that we're dealing with. So if we want to have an ellipse, basically we have to have it non-symmetrical. So A and C need to be different. Okay, so A and C need to be different. So what we could start with for this is we can say that A is not equal to C. Okay, A is not equal to C. But we also need to have A and C the same sign, because we don't want, if they're opposite signs, we end up with hyperbolas. So A and C have to be the same sign. So to do this, we can write it like this. We can say A times C is going to give us positive. And we can say that because if A and C are both positive, positive A, positive C, okay, A times C is going to be positive, or we have negative A, negative C, negative times negative is still going to be positive or greater than 0. Okay, so ellipse can be, we can kind of use this expression, but we can understand it this way as well. For a circle, circles are just ellipses. They are ellipses when A actually equals C. Okay, when A and C are the same, then we have a circle. Now, they both can be positive or negative, so we can just say A times C is greater than 0 for the same reasons, right? Because if A and C are both positive, it's bigger than 0. If they're both negative, it's still bigger than 0. So a hyperbola. Remember, hyperbola and ellipses go together. The rectangular hyperbola and circles go together. Okay, so hyperbola, we want that to be asymmetrical. So we need A to be not equal to C again. Okay, so we need since they're opposite sign, we probably should do this. Absolute value of C is not equal to the absolute value of A. But we need these also to be the opposite sign. Okay, so I'm just going to make this a little bit more clear. So not equal to absolute value of C. But they also have to be opposite signs. So if they're opposite signs and we multiply them together, we're going to have A times C is going to be negative or less than 0. So in this situation, this would mean that we have negative A, positive C, okay, or positive A, and we have negative C. Either case, A times C will be negative. And then when we move to the rectangular hyperbola, just like the circle, we need the absolute value of A to equal the absolute value of C. We need those coefficients to be exactly the same, otherwise it's not rectangular. But we still need them to be the opposite sign, so we need A times C to be negative or less than 0. Okay, so those are how we can establish those quadratics. Parabolas along the x-axis are going to be like this. So what that means is we need a y squared term, but we can't have an x squared term, because if we have an x squared term, then we end up with either a ellipse or a circle or hyperbola. So what needs to happen then is we need to not have A. Okay, so A must equal 0. Okay, there can't be an x squared term if we want the parabola going sideways. And C must be not equal to 0. Okay, so if that's the case, then we have this opening up sideways. For a parabola along the y-axis, if we want parabolas opening up this way, it's going to be the opposite. Okay, A can't be equal to 0, okay, because we need to have an x squared term, but we can't have a y squared term, so y must be equal to 0, or sorry, C must be equal to 0, because we got to get rid of that term. So these are the kind of ways we can establish, these are how we can look at these different the coefficients. In fact, we're only focusing on A and C because just those two coefficients will allow us to determine what type of quadratic we're dealing with. So let's take a look at this. Actually, before we do that, we should maybe mention this issue here. It's at the bottom. The general term does not contain the b. Where is the b? In fact, the b does exist, but we're not going to deal with it at all. Okay, the b exists like this: bxy. Okay, the bxy is actually 0 right now because we're not going to bother with that in this course. But what that term actually does, it actually rotates, helps rotate, spin the hyperbolas and parabolas and ellipses around, so they're instead of along the axes, they're at an angle. Okay, so we're not going to deal with, so bx exists, but don't use in Math 12. Okay, so let's do an example here. We're starting with the conic section. So this, first of all, identify the conic section. A is positive, B is positive, so the same sign. So it's either a circle or ellipse, and since they're not equal to each other, this must be an ellipse. Okay, so we're starting with this ellipse. We're going to compress this graph horizontally by 1/2, and then vertically expand by 3. And then we need to figure out the A and C coefficients. So to do that, we basically need to do the transformation and then expand, get rid of the brackets, and work it out that way. So starting with the x's, we're going to have 4x squared. Since it's a horizontal compression, okay, so it's a horizontal compression by 1/2, we're going to divide by 1/2 and put that in the horizontal compression. And there's actually going to be times by 2 at 2x. Okay, so if you want to remember it that way, that's perfectly fine. Plus, there's my y squared. Okay, and it's going to be expanded vertically by 3. So expand vertically by 3, I'm going to just put it as a divide by 3 in the denominator. Okay, and then that's equal to minus 16 equals 0. So I just have to simplify this and we can figure out our coefficients. So this is going to look like this. It's going to be 4 times 2x squared plus y squared over 9 minus 16 equals 0. The coefficients are implied to be whole numbers, so we need to expand this and multiply through by 9. Okay, so I'm going to end up with 2 squared is 4 times 4 is 16. 16 times 9 is 144 x squared. So there's my A, plus 1y squared minus 144 equals 0. Okay, so there it is. There's my circle. It's actually got a radius of x-axis radius of 1 and a y-axis radius of 12. Sorry, it's an ellipse. So just answering the question here, that A value, okay, so A is equal to 144. Okay, the C value is equal to 1.